We're finishing off chapter 4 today, which is on percentages and business math. Specifically, we're looking really at sections 4.5 and 4.6 today, which involve what's called reverse percent increase and also problems where you don't necessarily have a geometry given to you or a like any numbers other than just the percent itself. And you'll see what I mean. The questions are fairly they're fairly annoying if you're not a fan of algebra, but they can be dealt with quite easily if you just make some initial assumptions if you prefer, or you can just use algebra. So I'm going to go down here to section 4.5. So that'll just give me a second with that. All right, almost there. Page 23, for those wondering, page 23. So there's the, whoops. In my notes, it would be a little bit later because I insert a whole bunch of stuff. So there's the notebook page, is page 23. It's called reverse percent increase. So we ended off last class talking about how you can have a percent increase or a percent decrease, and we didn't talk about the reverse situation, which is what this section's talking about. In other words, if you had a percent increase or percent decrease, and you know the final value, and you wanted to go back and find out the starting value, what would be a practical example? Let's say that you went to, let's say that someone bought you something, and there was tax on the price, and then you asked them how much did you pay, and they say, I don't know, I'll just pick up a number, 150 bucks, and you turn around, you're wondering what was the original price before tax. So that's the kind of question we're talking about here: is what was the original price before a percentage was applied. So there's some schematics here that the author uses, which are really cool, and you can read through the book again. But the key thing, and I mentioned it here, is that wording is so important here. You need to pay attention to the question, because if I give you a question like this on the test, I'm not going to tell you if it's the final price or the initial price. Like, I will tell you, but you have to remember that it's a reverse question, which is a little bit trickier than the original questions we were doing on Wednesday. So to help you sort things out, I've just chosen 3 of the exercises, which you can find on page 25. Here's page 25. And you can see down here, there's 6 questions that I considered. There's one here, 7. It kind of reminds me of the next section. So that's why I would actually go for the next section before you come back to 7. But it doesn't matter because we're going to cover both sections today anyway. So it's all good. So bottom line here, let's do 3 questions and see if we can figure things out. As I mentioned to you, the wording is so important. So just take a moment and read question 1. So what's happening here is that the $54 represents what the price is after the discount was applied. Marco. Okay, so we're going to use, do you remember method 1 and method 2 last time? We're going to talk about that for a second, okay? So I want you to dig back to your thoughts about last class, and we're going to say that if you have 30% off, what does that mean? It's a discount or decrease. I'll just say discount or decrease because some people prefer one word or the other, of 30%. And what that means is this. In terms of what we talked about last time, it means you multiply the original price by, and here's the kicker, we need to get that factor. So that factor is going to be 100% minus 30%, which is 70%. I haven't commented on your answer, Marco, because I don't remember the answer. I don't remember the final number. I just wanted to work through it and see, hey, if you got it right or not. Let's find out. So what that says is that we have a factor for which we multiply the original price. So our factor that we multiply by is equal to 0.7. Remember that number. I'll put 0.70. You don't need the 0, but I'll put it there just so that it looks like the same digits are there. Anyway, we multiplied the original price by 0.70, and this gives us the discount price, right? Let's say that in algebraic way. Let x be the original price. You don't need to write the letter x. You could put a question mark. So you could be like this. So if I take this, let me get rid of that temporarily. I'll bring it back in a second. What it's saying is that the original price times 0.70 is equal to $54. That's what the question's saying. So if you wanted to solve for the original price would be $54 divided by 0.70. Marco, is that what you did on your calculator? Can someone check that number also, please? What do we get? Anybody have a number on that?
Sir,
Yes.
so I did 0.3 times 54, and then I got the number. A number, it was like 16 or something like that. And then I added 54. Was that right or no?
It's actually, no, it's not right. The
Oh,
final answer is going to be $77.
okay. My
This
bad.
question, it's all good. No, I appreciate that you're telling me because it helps me understand how you're processing it. See, it's really kind of screwed up, this question. I can't say it in a more professional way. It is really messed up because the process that you're trying to do is so weird. Okay, so here's my check. I'll show you with a little check here. Okay, check. Oops, not heck. I'm gonna check. I'll use method 1 to check first from what we did last time. If you take 77.14 and you multiply by 0.3, you get what? I'm just going to use my calculator here. 77.14 times 0.3, you get 23.14. And then you would do 77. This is based on Wednesday's class. And you see, if you subtract, you get $54. So that's good. The process here is a little bit confusing to do backwards because you have, yeah, it is very odd. It's definitely odd. But let me show you the, let me show you method 1, okay? So this is this is the check using method 1. Now I'm going to show you the check with method 2, and you'll understand why method 2 plays a role here. Method 2 is like this. We do 100 minus 30%, which is 70%, which is 0.70. And then here's the actual process. You do 77.14 times 0.70. And here's the thing, okay? This is a thing that I want you to focus on. Over here, this thing here in blue is the only real calculation that is applied to the money. This thing here is separate. That's easy to do. This is the only calculation that you apply to the money. In method 1, you have 2 calculations that are applied to the monetary value. 2 calculations being applied to that money. And that's what makes things confusing to go backwards. I'm not saying you can't go backwards. I'm just saying it's confusing to go backwards. So that's why method 2 is the way to go here if you want to save yourself some pain. So I'm going to underline that one and bold it. See, this thing here is easy to reverse. In other words, let me ask you, it's so simple. What is the opposite of multiplying by 0.7? Easy. Divide by 0.7. You see that? That's how cheap it is. But here, if I said to you, what's the opposite of this, not calculation, what's the opposite of this process? That's a whole process there. I don't feel like doing that. I'm not saying it like to you, I don't feel like doing it to teach you. I'm just saying it seems kind of unnecessary work. Going back to the question though, you do not have to create a variable. What I'm doing here about let x be the price, you don't have to do that. Okay, so if you don't want to write x here, that's fine. But if you want to put x there, you can put x here, and you can put x here, and then you have an algebra question. I'll get rid of that because I know that it might annoy some people, but I'm just showing you options. So now you've seen that, we're going to do this again for a few more questions down below. So first we're going to calculate the factor, and then we're going to apply the decrease or increase in this case. These questions are all decrease questions. So if there was an increase question, the factor would be greater than 1. So let's take a look here. A car depreciated in value by 18% over the past year. If the current value was 4,700, what was the value last year, a year ago? So that means that it was worth more last year. In other words, we're going backwards. So we can say that the 18% decrease is really 100% minus 18%. Thank you very much, Nikolaos. This is 82%. So that means that our factor, our multiplying factor, is 0.82. And then the OG, the original price, just kidding. The original price is equal to 4,700 divided by 0.82, which I will oh, thank you, Oakley. Saving me the effort. I like your style, my friends here. 5731.70. So I just selected a few here that involve decreases, but maybe we should do one that's an increase. So instead of doing 6, for those of you that have started 6, my sincere apologies. I'm going to do 5 instead because I want to do one that's an increase, okay? Because I should have chosen one that's an increase, so forgive me for that. For those that did do number 6, I'll just write down the answer for 6 quickly because it's only fair that for those that have attempted the question, I'll just state the calculation here. Well, actually, no, we're going to do 6 at the end. Let's do 5 first, then we'll come back to 6, okay? So just ignore 6 for a second. I just saw that right now. So we'll come back to that in a second. So here's number 5. We have a situation where the taxes have been applied. So we have here that there's an increase of 13%. It says that the price, including the taxes, is $316.27. So we're going for the original price, meaning that we want to go before the tax was added. So we want to undo that increase. So we know that the factor is going to be 100% because it's an increase. You add 13%. So that becomes 1.13 eventually. And then we can actually go for the calculation. So we can say that the original price is equal to $316.27 divided by 1.13. You're expecting the answer to be smaller because before tax, it should be a smaller number. Anybody have a value on that? 200 something maybe? Thank you. Thank you, Marco. 279.88. So I just realized that I know that I didn't choose 5 originally, so I just needed to throw in a percent increase situation there. So now we've done 2 decreases and 1 increase. 6 is a bit more of like a puzzle kind of a question. And I'm just going to give it some more real estate because it's a little bit interesting. So let's just squeeze that up in there. There we go. So a worker's salary is reduced by 6%. By what salary would it have to be then raised to go back to the original? So in other words, you want to figure out the calculation that takes you back. So we got this. Let's take a look here, okay? So first, let's get that factor. Decrease by 6% means that we have a factor of 100% minus 6%, which is 94. Thank you. Whoops, I'm trying to talk and type here. 94% or 0.94. So here's the key. If you want to decrease by 6%, I can spell that. Mathematically, you need to multiply by 0.94. Therefore, so the operation is simply you want to multiply by 0.94. How do you undo this? How do we undo this? In other words, how do we go back to the beginning? Well, what's the opposite of multiply? Divide. So we're going to divide by 0.94. Okay, grab your calculator. Someone calculate this, please. 1 divided by 0.94. What is that? And give me lots of decimals. You divide because you want to do the opposite of multiplying. Remember, multiplying took you one way, and if you want to reverse that, then you should do the divide. Okay, the divide is to reverse it. Lots of decimals. Thank you so much, everybody. 1.06 y by 1. Because the 1 represents, you could do any number here, okay? You could go 0.94 times x and then x divided by 0.94 if you like. I just chose the number 1 because 1 represents a whole value. So what is 1 divided by that? You have that in the chat. 1.0. I'll just do, what does it say about precision here? Near its 100%. Okay, my God. So 1638. So we have 1.0638. And then you know immediately that you could write that as a percentage as 106.38%, which means that the percent increase must have been 6.38%. What I want to talk to you about here specifically is, and this is really important, if you're gonna walk away from today's lesson just with one thing that's new for you, and this goes for everybody because it's not obvious. If there's one thing new that everybody learns today, hopefully, is that if you go down by 6% to go back up to where you started, you do not go up by 6%. It's going to be a different number. See, they're not the same number. Because the reason is when you're going down by 6% and you're going up by 6%, the dollar value, if you're talking about money, at those two stages is different. So that's why, because the numbers are different, the value of the dollar amount, it won't be the same factor to get back home again. For those of you that are getting a little bit scared of question 6 and like whatever there, this question, if it appeared on a test, for example, would be considered a harder question. It wouldn't be considered one of those questions that's like, oh, it's easy, you can do it in, a minute. This question maybe takes you a few minutes because you have to kind of think backwards. The good news is, though, for your test, you have your notes with you. So during the test, you can have your notebook with you. You can skim through your notebook and take a look and see and find questions that are similar. Hopefully, the more preparation that you take, the less time it'll take for you to access the information. It's on 1 to 4, Cosimo. So basically everything up to today. Your test is everything up to today. I'm going to talk about the test once I finish teaching the lesson, okay? Sorry, Nicolas. I don't remember how many, I think it's 3 pages, but I'm going to talk to you. I'll talk about it. I'll talk about it at the end. I will dedicate time for your test to discuss it. But let's move on to the next section so that I don't, you know, leave you hanging here without the full knowledge dump. So here we go. We're gonna dump some knowledge on you. Okay. So let's take a look at this last section. Oh, by the way, there are 2 sections left. But I said to you the final section involving invoices and bills is not on the test. I'm not going to make you fill out an invoice for a test. I'm not saying it's a bad thing. I'm just saying we have to pick and choose because there's a lot of us here, and it just I want to take my time teaching a larger group than just skimming through everything without good effort. So read this title carefully. This is a strange one. Percent increase problems where no original quantity is given. Again, if a question like this appears on a test, hypothetically, see it says advanced topic, hard or whatever. So this would be considered like one of those like tough questions on the test. And if you're wondering if there's tough questions on the test, I will discuss that at the end of this lesson. So just put that aside in your mind that this is a harder question if you get a little bit rattled with it or a little bit intimidated. Just 1 second. Okay, so let's take a look here. Now, there's a very nice example here for you to read through, and I encourage you to read through it. It's written very well, and yeah, the reason I know it's written very well is because I was the one who typed out all these notes, so that's why I'm saying that. But anyway, we're gonna go here and actually I'll pose a question to you, and let's see what we can do with it. So here's the question. This question should help us clarify what it means in terms of these problems. So just take a moment to read that. Even if we do this one question today, I would be satisfied. Even just this one question, I mean, in terms of this section. So I really going to take this question and treat it very, very diligent with you. So we're going to solve this question 2 ways. We're going to solve it making an assumption, and then we're going to solve it with algebra without making an assumption. So the first method, if you want to call it a method, method one. Method one is just invent a square. So make up a square. So just make up a square. Okay, how big do you want our square to be? I'm going to draw a square on the screen. Everybody, let's draw. Get ready. Grab your pencils and draw a square with me. Okay, can someone tell me the measurements of our square? What do you want here? Do you want 5? What do you want? Pick a number. 10 by 10. Thank you, Marco, for making my life easy. You didn't say something like 2.83 or something. Anyway, oh, by the way, what are the units of the square? I'm going to be a little bit lazy here. So this is the first time I'm going to not put units on a figure, but you should put units in general. I'm just not putting the units to not distract us from the actual logic of the question, which is the key thing here I'm trying to talk about. So I'm kind of ditching a little bit the units here. Anyway, can someone tell us the area of our square? What's the area of our square? You should be able to do that in like what? 10 seconds? 5 seconds? Yeah, the area is 100. Again, if you're like, what are the units? I don't care what the units are right now, so respectfully. Okay, now what about this business here? The square has increased. The side length of the square has increased by 30%. So we have a new square. How big is our new square? Can someone tell me what these lengths would be? What would those lengths be? That is correct. Can someone show me the calculation that you did to get that? How did you get 13? That is the correct answer, by the way. I'm gonna explain it right now, Cosmo. I'm just waiting for one of our classmates here to potentially give us a clue. In your head. Okay, fine. I wanted a calculation on paper, but hey. Thank you, thank you. So what you see there is Nikolaos did 30%. Now, for the sake of the lesson, I'm gonna use method 2. Sorry. So when you increase by 30%, I mentioned to you that you could use two methods. The first method is what you're saying there in the chat, which is to take 30% of 10, which is 3, and then add the 3 to the 13. But for reasons I explained in the previous section, I'm going to do it using method 2. So I'm going to turn this into a multiplying factor, which is I'll take 100%, and because we're going up by 13, I will add 13. So let me just do it this way. It looks kind of pretty this way. And then you will have 113%. Sorry, I meant 30%. I guess it's because it's Friday. I'm just used to paying tax so much. So anyway, here, let's do 130. My apologies there. Yes, I can do math on Friday, I promise you. Hopefully you're laughing. Anyway, so that's equal to 1.13. So we're going to multiply, sorry, 1.3. So that's how Nikolaos and Marco were getting those numbers. We multiplied the lengths by 1.3. And we do that for each of the lengths. So even this one here, see, we're going to multiply by 1.3. Okay, so now that we figured out the new area and I've figured out how to do math again, what the heck is the question asking? By what percent does the area of the square increase? Okay, so I'll do that calculation here. It's a very familiar calculation from the chapter. That is correct, it's 69%. That is very good. Nicely done. So we're going to go here and say that percent increase. Nice. Percent increase is going to be this. It is the increase amount dividing by the starting value. So if we do that, and I'll do the 100% here if you want to see the 100%. So the increase amount is 69. So then we have here 69 over 100. Which is 69%. So again, if we just do this one question, I would be very, very happy. But there's one thing that I don't like about this solution. There's something that rubs me the wrong way, okay? I don't like it. And that's the fact that we assume, why do we have to assume that the square is going to be 10 by 10? Why do we need that assumption? We don't need that assumption. So for example, and try this on your own later. Anybody that wants to try this later, that'd be a good exercise. Instead of 10 by 10, make it something else. Make it something nasty. Make it something like, I don't know, 98.4. Make it just a ridiculous number. Like just a number that makes your life annoying. Anyway, the thing is that you do not need this assumption. It should work for any of the lengths. But in terms of performing well on questions and writing tests and all, if you want to do the question by assuming 10 by 10, then you should do that. That's fine. You will get full marks. I promise you. If you use 10 by 10, you'll get full marks or whatever numbers you want. Now we're going to do the same question with a second method. And I'm just going to drag down all of this good, wholesome calculation here. But we're going to call this method 2. Make up a square. Not this time. We're not going to make up any side lengths. We're going to keep it all general. So my friends, welcome to the pain. Just kidding. Welcome to algebra time. So instead of 10 by 10, we're going to go x by x. What's the area in terms of x? Can someone give me the area if that is x by x? It's not too dangerous, hopefully. What would that be? Anybody in the chat there? What's the area? What's the formula for the area of this square? Thank you, Tamerlan. Always clutch. And Sheldon, Nicolas, thank you. My friends, you are clutch today. There you go. X squared. Now, the old square is going to be x. I'm going to just put a star here so you don't think that's like an x there. That's just multiplying. So we're going to multiply by 1.3. So this is going to become 1.3 x. 1.3x. What's the area of our new square? Can someone multiply those together, please? So 1.3 times 1.3 is 1.69. And x times x is x squared. Very good, Cosimo. And then the x times x is the x squared. Beautiful. So we're almost there. We're almost there. We're almost out of the woods here. Let's take a look. How did I get 1.3? The same way I did in the previous. Okay, wait a second. How did I get 1.3? What I did up here. It's the same thing as the previous part. It's still 1.3. It's still up 30. All this stuff in blue is the same. I didn't change anything. All I'm saying is I don't want 10. I'm going to use x. But everything that we did in the previous method is the same. It's all the same stuff. The 1.3 comes from earlier. I got it earlier right here. If you go up by 30%, it's equivalent to multiplying by 1.3. Now go back here. You're welcome. Let's go back here now. We have the increase amount. So we're taking a look here. I'm gonna type a little bit here because it's just the last piece of the puzzle down here. I know that the increase amount is going to be here. It's the change. So it's 1.69 x squared minus x squared because it's the final area minus the initial area. If you want, I'll say final area minus initial, initial area, okay? And then if you subtract those two things, you get 0.69 x squared. Over here, the increase amount is 0.69 x squared. The original amount is x squared. And can someone see what's going to happen here? What happens to those x squareds? What happens to those x squareds? They disappear. Bye-bye, my friends. See you later. So those x squareds disappear, and they cross each other out. They cancel. So then you have it. See, the answer is 0.69, and 0.69 times 100%, or just 0.69, is obviously 69%. So method 2 is a little bit more intimidating because of not using a number for the side length, instead using a variable. However, the reward is that you calculated the answer, the percentage, without making any assumptions. You have demonstrated it, you have proven it without making any unnecessary assumptions. And that's huge. That's very big because it's something in math. When you want to make an argument to somebody about something, whether it's correct or not, you can use an example and say, well, this is my example to show you. But it's another thing to prove it for every possible situation. What we've done is we've proven it for any square. Here, we've only demonstrated it for a square that was 10 by 10. Here, we've demonstrated it for all squares. Big difference. Okay. I'm glad you see. Now, I said to you, just doing one example here would make me very happy. And that's why I went really, really slow on this example. I did two methods. I did one method with algebra for the people that prefer not to make the assumption. I did another one up here earlier, which was much safer, easier to get because it's just calculating numbers and comparing numbers. Like here, you see, we wrote 69. And nobody asked the question about where I got 69 from because it's the increase. You just look at the numbers, see 100 and 169. But over here, excuse me, the increase is x squared to 1.69x squared. So the difference is a little bit more complicated to digest. One moment, please. Okay, so I promise you a discussion about the test. Before we do that, we should take a look and maybe try one more question. So on pages, let's take a look here. I'll post these up on Blackboard at the end of class. So pages 29 and pages 30 have additional questions that you can play with. And all the answers, of course, are down below. What I'll do is just maybe tackle another question involving, let's take a look here. We're going to do question 2, and then we're going to do question 7. I'm not trying to do less. I know that some students do want to understand a little bit more about the test. And I do, since it is our first test, I should dedicate 5 or 10 minutes discussing exactly the process so that everybody's happy. So let's do question 2 here. If each dimension of a rectangular box increases by 20%, by what percent does the volume of the box increase? So we're not going to play any games here. We're going to actually kind of steal what was said earlier. So who originally said 10 by 10? Remind me in the chat because I forget now. Who said 10 by 10 for the other question? Marco, thank you. So I'm gonna just do something like Marco there. I'm just gonna pick numbers that are very friendly. I'm not gonna try to make anybody's life miserable here. Here's the new box, make it bigger. See how it's a little bit bigger? Look at that. It's not to scale. So if you measure with a ruler and come back to me that it's not to scale, my response will be, sorry, didn't mean to. Anyway, let's take a situation here with a rectangular box. You don't have to do what I'm doing here. You can do this with algebra, but I'm going to do it here just by using numbers because maybe it's a little bit easier for you to process, which is fine. I'm going to make the width 10. I'm going to make the length 30. And of course, people, it's not to scale, okay? It is not to scale. Do not come back to me and say, oh, it's not to scale, sir. I understand. So anyway, what does it mean to increase by 20%? Can someone tell me what we would multiply by? What do you multiply by? So if you increase by 20%, you're going to multiply by 1.2. Thank you, Tamerlan. Remember in the previous question, we increased by 30%, if you dig back there, and we multiply by 1.3. Yeah, exactly. It's 120%. It's okay. So what I need everybody to do is just grab your calculators, and we're going to take all these guys here, and we're going to multiply them all by 1.2. So this is the cheap way. This is the cheap way where you're making an assumption about the length, but you can prove it in general on your own as well. For the sake of time, though, I'm not going to do the proof. Okay, yeah, thank you. Start tossing some numbers at me, everybody. So this is 24. How much is this one? 12. And then the one, whoops, 36. Oh my goodness. So this is such frustration. Whenever I hit the record, the stylus starts to go like a snail. It's so weird. Anyway, I'm going to do the math by hand. Oh, thank you for that, Nicolos. Thank you. So the original volume, sorry. The original volume is going to be 20 times 30 times 10. So that's 6,000. I know that this test is not about surface area and volume. It's not the explicit topic, but I do expect you to know the area of a rectangle and maybe the volume of a box. I'm not saying there is a box on your test. I'm not guaranteeing anything like that. I'm just saying be prepared to be able to do basic calculations like that. That's the original volume. Now we have the final volume. You can even say an initial volume if you want here, if that is your preference. Anyway, the numbers were given to us by, let me see here, Marco, thank you. So 24 times 36 times 12 is this annoying looking number, 10638. Thank you, Nicolos. 10368. And there you have it. We have the initial volume and the final volume. I'm just going to shift that thing over there a bit so we can do the change. We're almost done the question now. So final part of the question is here. So the increase, how much did it increase by? Let me know in the chat. How much did the volume increase by? What is that, 4368? Good. So then the percent increase is going to equal the 4368 divided by the initial amount, which is 6,000, times 100%. Can someone write that as a percent final answer? With one, like just as a percent, or just compute that, please. 72.8. Thank you, guys. Thank you. So I'll just say your increase of. It sounds better. If Word complains about grammar, I don't care. They can take their grammar and go complain to someone else. There we go. 72.8%. So in other words, if you were to increase the volume, the length of each of these measurements or dimensions on this figure by 20%, the overall volume goes up by 72%. Keep that in mind. If you thought the final answer was going to be 60, because you know 20 plus 20 plus 20 is 60, that's not correct. It's a good guess. It's a good starting point, but it's not the correct answer. Because when you find volume, you're multiplying, right? You're not adding here. Do you add here? No, you multiply. So why the heck would you add percentages when the operations below are based on multiplication? So that's why these scaling up questions are very, very interesting. And finally, just to kind of say one more thing on this question before we stop with it, where is it practical to discuss these types of problems? Blueprints. When you look at a blueprint, a scale diagram, for example, a map, you can use information off of that with the scale or the legend, and that will help you make estimates on areas and lengths and distances. One more question, and then we're going to go and talk about the test for a bit. So this is our last question from the book. And we're just going to do question number 7. Just the one last question, okay? This is our last question today. And then I'll stop the recording, and then we will talk about the test. Okay, so it says here, if an 18% increase is followed by a 14% increase, what is the effective percent increase? By effective, they mean overall. They mean overall. So 18% means what? Multiply by what? Can someone tell us? What if you have 18% increase, what does that mean you multiply by? It's the factor. 1.18 is correct. It's 100 plus 18% respectively, or 118% or 1.18. That's the factor. Multiply by a factor of 1.18, or what we've been calling method 2 today and on Wednesday. Same thing with 14. I'm just going to copy and paste it. So 14% would be 1.14. You don't have to write out the second one. If you were writing a report or something, you could just say similarly. You could just say this, similarly, and not write all the stuff down. Okay, you don't have to, it's the same operation twice, and you're not a robot. Just copy, if it's fast for you to copy and paste like me here, if you're doing it by hand, just say similarly. Anyway, so we want to now take those numbers and combine them. So what that means is, originally we were multiplying, we're going to multiply by 1.18, and we're going to multiply by 1.14. Instead of doing them separately, why don't we combine them? If we combine them, can someone tell me what 1.18 times 1.14 is? And just keep all the digits. What do you get? Thank you. I'm just recharging with my coffee for a second. Sorry. 1.3452. And that's the answer. It's related to the answer. So we're going to have here, let's finish it up here. 1.3452 is equal to 134.52%, which means that there was a 34.52% increase. That's the final answer. I'm kind of glad that we did this section 4.6 with 4.5 together, because they kind of do nicely go together. And also, we did cover a lot on Wednesday, and I felt that we should give you a little break here in terms of finishing off Wednesday's class a little softer than usual. Anyway, I will post these solutions on Blackboard as soon as we're finished the class, but it's almost time for us to wrap up the lesson. So let me discuss the test a little bit with you.